Welcome, Jean-Eric. You and your team have 20 minutes, absolutely no more. So
Thank you
speak,
so much.
share with us.
Yeah, so great to have this opportunity to speak about how we're using OGC standards to create this open interoperable AR cloud. So yeah, we're all volunteers here on this slide from the Open AR Cloud Association. I'm the managing director. I will be introducing the Open Spatial Computing Platform and trying to explain how that connects with the standards. And then Gabor and Ali will speak about some clients that are connecting to the platform and using the standards. So next slide. I just had to ask OpenAI's DALI how it understands AR cloud, and maybe I did some good prompt engineering, but I think this is pretty spot on. We're kind of in the city scale. We're seeing points of interest. We're seeing three-dimensional objects, and it's down there at the pedestrian level, hopefully enriching their lives with very useful information. So next slide, we can look at how if you go, yeah. So the GIS crowd, they might think of this as an upgraded map that is become three-dimensional and it's real time. And there's the notion of the representation of the actual world, the classical map, but for the era of spatial computing, and all these layers of content that you connect to that. So next slide, we're gonna see kind of the maybe there's audio, I don't know, but this is 3 years ago from Snap. It's not an open platform
Jean-Eric,
that way, but
there is
are
audio.
you
Can
seeing
you
this?
speak now? Can I hear you?
Yeah, yeah.
Yes.
I can hear. I can hear you.
You can hear me?
I can hear you.
We hear both. So,
Yeah. Okay. So we can move to next slide. So if you saw the So what you saw was kind of how you can experience air clouds from your device, like, and this is a shared experience and it's tied to the real world. That's kind of the essence. And there's a bigger context of all these different technology areas that kind of converge around real world spatial computing. And the important thing about the AR cloud is that that is a way that you can connect as a human being into this larger ecosystem of advancing technologies. But there's a challenge if you move to the next slide. There's a lack of interoperability in this space. This is still early days, but everything looks like it's dominated by these proprietary platforms that doesn't work together. So everyone is trying to get people into their app store happening on their terms, and not being easy to move to another, not having the freedom of choice, and all sorts of not necessarily great business models. Next slide. So for this says 30 years here. It's actually a few days ago. It was 35 years ago since the idea of the open web platform started to take shape. And this is kind of the inspiration we should take for how to make the open air cloud interoperable. There's a few set of standards, protocols, services, and clients that all work together, and where different players in the ecosystem can implement to support those standards. And that just works great. So next slide. So the idea here, we're taking this inspiration and we're imagining that there could be this future open spatial web platform. So next slide. And this is more or less what we put on a slide in 2019. This was actually before the OGC GeoPose standards working group was set up. But in our list of standards, protocol, services, and clients for this future, we imagined something like GeoPose would be at all levels, all around the platform. So I'm going to try and go into a little bit of detail how this platform works. The next slide. So if you look at the bottom, there's these AR glasses, and you can imagine that this has some understanding of the protocols on the client side. And the first thing it does is to reach out to the top level, the root level, where it's sort of like DNS. There's this set of records describing spatial services. So there's all these kind of spatial computing services that you can be found, and you ask for those services around where you are. So the first thing you might want to do when you get the result there is see if there's a GeoPose service nearby. And if there is, next slide, you send up a little bit of imagery or sensor data to that service, and that service will return OGC GeoPose, that kind of data structure that we have encoding that we have described in OGC. And next slide. So the client now understands with an estimate from the service, it's GeoPose. And it can ask spatial content discovery service. If you go to next slide. And there are different types of records there. There's content records. And for some of those records, there will be GeoPose, so that if it's a 3D asset, it will have a GeoPose in the real world, allowing the client to display it properly, three-dimensionally. Next slide, please. And this is not implemented yet. There should be, in the not too distant future, a protocol for sending your GeoPose back up to a cloud rendering service. So the device might not have great compute capabilities, but at the cloud edge, there might be servers with very powerful GPUs that you could leverage, and GeoPose would be excellent for that. And next slide, please. So this is the thing that is happening now here in Delft. For the first time, we're using the POISE that is developed by OGC, and the client understands the POISE, and there will be service endpoints that has POI data. So this is exciting. You can go and try outside later if you wanna. Next slide, please. And one final remark on this is that as Jeremy said, you only need to implement one target. And we say that a little bit like in the machine learning world, where they say attention is all you need. We have decided for this ecosystem that basic quaternion GeoPose target is all you need. Next slide, please. So now it's demo time, and it's gonna be the web app that runs on WebXR that the excellent Gabor Soros will talk about, and then after him, Ali will go on with the native app. So thanks, everyone. And over to Gabor.
Okay, can you hear me?
Yes, we hear you beautifully. You don't need to turn your video on because we're not showing it. I can see you, you know, hi, but nobody in the room is. It's completely up to you.
Okay, so welcome everyone. We thought that for this OGC meeting, we will prepare something which is an open source application using open web technologies for an AR session, using open protocol for geolocalization, retrieving objects associated to geoposes, and then showing some contents that are basically open standards for point of interest. So this is what I'm going to talk about. Next slide, please. So basically, we don't need to spend too much time on this slide because Jan Erik already told you the vision. So we want to have geolocated contents and discover them really depending on where you are at the moment, and then showing them on your screen. And I see just right now that we actually anchored a huge typo in front of the OLA. You can discover it yourself after the demo. So next slide. So why build a WebXR clients? Many people use Unity today, but still installing an app is kind of inconvenient. There's no real compatibility between those apps. But the biggest advantage, I think, is that triggering an AR experience is really like going to a website. So you can actually click on a link, and then you open the app, and inside the app you can click on other links of contents, and then you can actually continue browsing and open documents and so on. So it's kind of universal. And ideally, a wide range of devices should be supported. The fact is that currently only Android Chrome has a full functionality for this. So you can only try the demo with an Android Chrome. We will also show this link later, but you can take a photo of this QR code if you want to start the app afterwards. So the main problem is that other devices don't provide camera access functionality, and we somehow need to get an image in a browser from your camera to be able to localize it. Next slide, please. Because we use a visual positioning system, there are many of these systems available today. Some of them are proprietary, most of them actually, and we use one startup called Augmented City. This is how their map looks like. So we basically collect a bunch of photos in front of the TU Delft building, and there is a point cloud reconstructed from them. This point cloud is aligned to the OpenStreetMap. And then at query time, you send one picture to the server, and it determines your GeoPose, the GeoPose of your camera. And then the client retrieves from the Open Spatial Computing Platform, retrieves all available contents that are around this place. Next slide, please. Yeah, just if there is no visual positioning available at your position at home, for example, you can still fall back to sensor-based localization, but it's not going to be as accurate. So for this demo, we use visual positioning. Next slide, please. We also created a simple admin interface for creating contents, attaching them to geolocation. So this is how a spatial content record looks like. You can specify a name and a type of like a model. Add some keywords and the GeoPose, and then there's a small model viewer. Next slide, please. There's also a small map view where you can specify where you want to put your content. This is in front of my office, and important that everyone has read and write access at the moment, so you can see everyone else's contents and everyone else can see your contents. Next slide, please. What kind of contents are supported? Currently, this list, simple GLB models, icons, OGC point of interest, which is new, and some GeoPose streams, which we try to utilize in the Metaverse Standards Forum. Next slide, please. And this video should start automatically. Yes, this is how it looks like. I start my camera. I look around in front of my office. I press localize, which means sending a photo to Augmented City. They determine my GeoPose. And I immediately retrieved like the cafe, that's Pad Thai Wok Bar, the Nokia office entrance. So these kind of poise that we created. This is a famous statue. This is a mathematical shape. And poise can even have heights. So if I look up, you can even see that nice meeting room with a great view up there. So this is the kind of experience that you can get with this WebXR app. Next slide, please. And this is one more last demo I want to show is here I have multiple devices. I localize both of them by pressing the localize button. And what happens is that if I click on the floor, because with an AR device, you can actually click on the floor, I can calculate the geolocation of that click on the floor. And I spawn a virtual object there, which is just a random object with random color and random shape. And I send that, broadcast that over the system, and the other device would receive it. And ideally, if everything works, then the object should show up at the exact same location. And to prove you that this is not a shared AR session between devices, which is possible with AR Core and ARKit easily, here everything happens in GeoPose. On the right side, we see an OpenStreetMap view, and we can see the same objects appearing there. With the same colors, and what is even cooler, you can do it reverse. So you can click on the map and spawn these objects initiated from OpenStreetMap, and they will show up in somewhere in the background. These objects will show up in the AR view. So you can actually place contents in front of somebody walking on the street. Okay, next slide. Maybe we will hand this out later. This is just describing how you can start the app, but I think Ali Hantal is there and he can help you right after the session. So we can go over to the next presentation. Thank you.
Fabulous. Thank you. Thank you. Yes, it's good stuff. Interoperability. We're like, so Ali is here in person to tell us what he's been working on with Yavuz and welcome. Welcome. Ollie's been here for 2 days to make sure.
And you be. Yeah, to make sure that the demos that hopefully we can go after this will work. I can help you with the demos. Next slide, please. Yeah, what we have is a platform, a spatial content management.
Maybe you should come over a little closer to the mic so it records it.
Sorry.
Thank you.
Sure. So what we have created over the last few years was a spatial content management platform, which is using the GeoPose 1.0 standards. And what we do here is, if you can see that on the left, there is a back office where actually, like the one that Gabor showed, you can log into that and then start adding content, or you can upload your own 3D model to our platform, and that could be GLB format, which actually I'll show you in a minute that we uploaded a OGC logo, which is GLB, and placed it in front of the Aula Center, and we'll be actually viewing that also with Gabor, the Sparkle Web XR client. And we can actually we have several other functionalities on the MyGeoverse platform, but one thing that I already did there is we can also create dynamic signs and AR wayfinding. We also added some AI ability. There's an LLM working at the background, and you can choose to have breakfast with Einstein and talk to him while you have his avatar in front of you. The most important part about the platform is it has localization, different localization methods. AC is Augmented City, one of our OpenAir Cloud partners who actually provided this VPS here. Then we have Google VPS. You can also use GPS, marker, or just simple place or others. Next slide, please. Next slide, not flight. Yeah. So if you would like to try this demo yourself, please become a tester. You would just need to download our app and then send an email to tester@xrmasters.com so that we'll send you an invite and you become a tester right away. There's the team waiting for you, and then you will just need to go to your invitations to accept that, and then you'll become a tester. Next slide, please. Then what you'll do is you will go out, and as shown here, we also have a video on the app to show you how you can localize. You'll just look at the building. I'll show you exactly where you should be standing for this purpose. Normally it's a 360 scan, but right now, just to make it, I will show you where to stand, and then you'll localize by just hitting start. Next, please, Kristen. Then if you would like to create your own POI, you will just select create POI on the menu, and then as usual, just look at the ground and then where you want to place the POI, click the screen, and then you will write the POI name, your email, and you can leave the rest actually blank, just write a name, it will work. Next slide, please. When you create POI, actually I'll show you on the next one after showing how to place a GLB 3D logo. The same thing, you localize, you go place content, just write OGC when you see the content database. And once you pick that up, again, speak wherever you want to place it. And once you tap to place, it will be placed. Now, next slide, please. And this is how what you will be seeing. On the left, I just created flags, POI. And when you turn left, you will see the flags on MyGeoverse. And then if you click on MyGeoverse only, because WebXR doesn't support the click function, you will see the information about that POI. And if you turn right, there is this salami art structure on the right. You'll see the OGC logo that I created and I placed. That's a GLB format OGC logo. And you can see that the GeoPose is working for the GLP, as well as we have the POI there. And next slide, please. If you would like, you can actually look at this QR code, and you can go to the web page that we have explained everything that I showed here, so that you can actually on your own do this when you get out. And if you have any questions, I'll be there after the session, and I'll be here actually after the session. So please let me know.
Yeah. All right. Thank you. That was amazing. 20 minutes and 35 seconds.
Wow, we're on time.
Congratulations. Thank you very much, Jean-Eric. And that was
Fantastic. Who would have known?
really, really incredible. I hope that we can keep to the same timeline. We have one more presentation. This is, let's see, can you see it? Yes, you can. I'd like to welcome Mikel Salazar. Mikel, are you with us?
Yes, I am here. Can you hear me?
Yes, we can hear you perfectly, loud and clear. We see your slides on the screen. So I'm going to set just a tiny bit of context here. What you saw was information presented by Jeremy at first, just the basics of GeoPose 1.0, what's included, what's not, what's in scope, what's out. Then we spoke about the Hilly Fields bubble set, which is a way of, we captured GeoPose so that things could see each other and knew their relative positions to each other and their absolute pose location. Then we had 20 minutes about how the open spatial computing platform, which was actually the genesis for the idea of the GeoPose, has implemented GeoPose in a variety of ways using the Discovery Service. We've worked with partners to create the visual positioning service, clients, native clients, web apps, a lot of, this is not trivial. This is years of experience. So what we want to do is we want to make sure everybody has an opportunity to do that, and other businesses. Our next phase of growing up is to make sure this gets implemented in as many places as possible. Standard is only as good as the number of places that it's implemented. So Mikel has been with us through all this journey. In fact, one of the features of the web app is a signpost that Mikel created. I think you can select that, and it is GeoPose sensitive, so it's oriented with respect to cities that are on the other side of the globe and so forth. Mikel, being a developer and a 3D modeler specifically, has been an active participant in our working group to keep us honest with respect to 3D developers. And his role has been to create this sandbox of GeoPose tools for developers. So welcome. Thank you, Mikel, for your work and being here today.
Okay, thank you very much for the presentation. Yeah, if you can go to the next slide, I present here the GeoPose sandbox. You can have access to the GitHub repository, and I am finishing a version that hopefully today or tomorrow will be available with the new things that I am going to present today. So next slide. Yeah, what is the GeoPose sandbox? It is important to know what it is. Next. It is right now mainly a TypeScript implementation so that we can create JavaScript code at the end of the day, and with it create the websites and web apps from it. Next. It is a developer sandbox, so it is an experimental implementation and not very optimized, but it is very great, good to test new ideas and incorporate new features to the standard in the future. Next. We are using 3GS, a popular 3D engine for the web, so that we can make the current solution interoperable with other systems. And yeah, it is a great solution for many developers, web developers. Next. And what I am working in this right moment is how to use this very GeoPose sandbox to create things like the website or the presentation of this of the GeoPose sandbox itself by showing rather than telling. Next. Yeah, but there is still a lot to be done, and hopefully with your help we can make this GeoPose better, because at the end of the day this is something that it's a collaborative effort. Yeah, in general, just to show the structure, it's very simple. But next, we have the builds with the ECMAScript modules and several bundles, so that it is easy to work with different things without having to worry about the different libraries that are included. Next, several exam documentation with code snippets that I will show later, an auto-generated IP reference. Next, examples that with a small collection for web apps, including the project website and the slide deck for this presentation. Next, the sources with 3 different parts, so that you can just take the data where everything is connected, or you can get the logic representation of the different entities, or if you want everything already done, you can take the both data, logic, and user, and you will be able to create web apps in a second. Next, the test, so that you can see the different features, and finally the utilities to visualize and test the different things. Next slide, please. Yeah, it is important to mention that there is a data model that you can use, but it is like the abstraction of GeoPose, containing the general poses, not just GeoPose, but any kind of pose. Next, with a frame that can be, normally is the Earth, but can be any kind of visualization 3D frame, so that we can take advantage of Minkowski spaces, Euclidean spaces, any kind of coordinate reference system that you can think. We can abstract it into this class, so that it is easy to build poses on top. Next, the position, containing both the position, the translation, and initial rotation, so that we can create the transform rather easily. And then the rotations, we have different, next please, orientation rather, the rotation of the pose after applying the previous transformation, so that we can use quaternions, yes, but also pitch roll. We can have like orientation, like look at orientation, or those based on an angle and on an axis or an angle. There are many different ways to do this. Next, and of course we include an extension system, so that you can include time, color for the point clouds if you want to use this GeoPose to represent different kind of things. Like every GeoPose can represent a point in a space. It can represent obviously, but also it can be a point of a point cloud. It can be a sensor. It can be a lot of things. So we give you the ability to extend GeoPose rather than integrate GeoPose into something. You can actually create and extend the standard, so that you can propose new solutions. Like the idea, oh, I want time in this way. I want this other property, so you can use it. Next. Yeah, I have several examples. If we have time, I will share my screen.
Yeah, I can make you presenter. Let's go ahead, and it seems like we are on time, so I'm going to give you that. Oh, is that somebody else is doing that?
Well,
yes.
Well, I am sharing my screen since I am able. But yeah.
Wait, just a second. We don't see it locally. Okay. So I'm going to go here, and I'm going to go to
make me presenter, I guess.
What am I going to share here?
Well, you don't have to share. You what you do is you need to mirror your screen.
Okay, that's different. Okay, there's a software update.
Let's see. I'm not going to do it that way.
Yeah. Okay.
I don't know where it is.
It's yeah, it's in the.
Okay, now Mikhail had it right.
Yeah.
You can go ahead and share now, Mikhail.
Okay.
Are you?
Yeah, this is the GitHub repository where you can see the latest version 5 months ago. Hopefully, I will upload the next version today. In the developer branch, I have to mention there are 2 branches. But for example, some of the examples that we have been working on is the ability for us to place and create any kind of space. And yes, normally it's the Earth, but we can say like, okay, how it will be on the moon or in any kind of a space, with the idea that we can create all kind of ellipsoids or apply GeoPose to all kind of celestial bodies, or even things that are not proper celestial bodies, like the ability to create a geometric space and place anything on it. And also, in this case, you can see that I can use the very same GeoPose sandbox to create my own presentations with this sphere, globe behind the slides, and be able to create all kinds of interesting web presentations and display them for other people to see, rather than telling you how geospatial content works or how can we position elements on the Earth. And of course, there is, I am working on a GeoPose AVI reference with all the different classes so that you can have a proper documentation. And more importantly, here, you can see that I am working on different code snippets so that you can easily copy and paste and have your own implementation of GeoPose in any language that you want. In this case, it's a little bit still JavaScript center, but my idea is that we will have different versions of the different basic implementations so that you can copy paste this code and make it work in any project that you have. And with that, I finish my presentation.
Good job. Good job. Yep. Thank you, Mikkel. So there was a lot of information conveyed in a really short period of time, and you know that's how it should be, right? And one of the things I wanted to point out, there's let's see, that's available for people to get back to the sandbox. I want to say that this principle of having running code sandbox available, this is our our investment, and it is a significant investment to getting more people up and running. There's a video that was downloaded. It's in the meeting folder file for this. There's a video that Ali recorded about what we're showing outside. I want to make sure we got sign up. Everybody's going to go outside on your way to the lunch to go and see the demonstration. Yes, Greg.
Video is not in the form yet. It's on the desk.
It's on the desktop. Okay. So perhaps I think it has no audio, so I could even play it without, and then I can tell you what there it is.
Yep.
This one.
Exactly.
And wait a minute. Wait a minute. I want to give it a. Can I make it bigger?
Yeah, it's not going to be bigger. I think.
That's good.
So this is Sparkle with an Android phone. It just localized, and you can see the flat pulley that was created and placed by MyGeo's native app. And this that spinning OGC is placed there by Gabor, but the right OGC logo is created by
MyGeoverse.
And you can also see some other pulleys around that you can only see with Sparkle, because that was created by Sten's, I think, pulley provider. Sten provided that.
Mm-hmm.
And this is the, when you get the app, you will see a welcome screen, and then how to localize video. This works locally, actually, location based. So wherever you are, you get a correct video in the app to show you how to localize. So I'm localizing now. As soon as localize, there is a sign that says welcome to OGC demo area, and then If you look left, you will see that flags pony at the same place, exact location as the other one that you see, and this is the OGC logo that I created. So we cannot see what Sparkle placed, but Sparkle can see what we placed. Currently, we didn't finish that side up, but the standard works on one way right now.
Really good. So we have 9 minutes left. We're supposed to have 20, but I think given who we have in the room and what we're trying to accomplish, I'm very, very pleased. And I want to thank all those who worked very hard to get it to this stage.